Good morning, everyone. My name is Melissa Welsh from Scion. I'm going to be presenting to you a bit this morning about the logistics and economics around harvesting automation. So also involved in this project with me is Karen Bain and Oscar Montes, also from Scion. Ha is a master's student from Massey University who's been quite involved in some of the extensive modelling we've done with this project. And Robert Radix from Lincoln University has also been quite involved initially in the setup of this project and helping us carry on in some of the validation process. So a bit of an overview of what this project is about. So we're looking at the current harvesting process and introducing a new harvesting process which is more automated, along with a robotic sort yard. So we're taking, instead of leaving so many logs on the landing, they're just sent directly to the sort yard and sorted there and taken to the port or the pulp mill or the mill. So this is reducing a lot of the logs stacked up on the landing, which is a nice health and safety benefit, as well as increasing the efficiency of log throughput. So this is a diagram of what the conventional ground-based process looks like. And this is an automated version of the ground-based harvesting process. So some of the differences here to highlight is we're reducing the number of chainsaws involved, essentially removing them from the process altogether, but there may be one left on site as just in case. The grapple processor is being replaced with a processor debarker. And we're also introducing an automated chipper to the landing so we can process trip and remove slash, etc. that might be on site as required. And then along with that, we're also introducing a chip truck which takes that chipped material to the pulp mill. Another benefit of this is that the conventional ground-based process involves 7 personnel, while in this new automated process, we're able to reduce that to 5 people needed on the landing site. So the mechanized hauler process is illustrated in this top diagram here, while the automated hauler version is shown down the bottom here. So again, we're reducing the number of chainsaws involved. Our metal swing yarder is replaced with a semi-automated metal swing yarder. And this grapple processor loading area loader process is now being replaced with a processor loader debarker. So that's all happening with 1 machine rather than 2 or 3. Again, we have the automated chipper to deal with our chip on site on the landing. And this conventional process in this case involves 9 people, while the automated process only requires 4. This is a diagram of what the sort yard looks like. So we've got our truck unloading to the which loads onto the log sorter, which excludes a debarker because the debarking is now happening on the landing site. And those logs are then either loaded directly onto the truck loading gantry to be sent off to where they're going, to the port or the mill, etc. Or they're put into log storage to wait for the truck to be available for them to be loaded onto. So all of the logs that are waiting around in storage are now waiting down at a sort yard rather than up on the landing where all of the harvesting is going on. So look at how the trucking is changing in our new automated process. So the current process, we have logs going straight from the landing site to either the mill or the pulp mill or the port. Whereas in our new process, all of these logs go from the landing to the sort yard. So they're all going to the same place as soon as they're harvested. We don't have to sort them on site to figure out where they're going to go. So they're sorted at the sort yard and then sent to the pulp mill or the port. And another benefit here is we can use the best trucks appropriate for where the material is going. So from the landing to the sort yard, we can use tracks that are optimised for transport within the forest. There's going from the sort yard to the final destination. We can use tracks that are optimised for transporting logs on the road. So just a quick side-by-side comparison of the two models. So we have our 3 conventional ground-based crews are being replaced with 3 automated ground-based crews. Our 2 conventional hauler crews are being replaced with 2 automated hauler crews. Our 1 conventional 2-stage crew is being replaced with an automated hauler 2-stage crew. And we have 2 conventional mechanised hauler crews being replaced with 2 automated mechanised hauler crews. We've also introduced the sort yard to our automated model. And the number of people involved has gone from 64 workers in the conventional model down to just 53 in the automated model. So this is a picture of what the simulation process looks like in XtendSim, just to give you an idea of what we're working with. And this here is just a short video of starting with the ground-based crew harvesting process and then moving into what the tracking looks like. So this is everything going directly from each landing site to the port or the pulp mill or the mill. And by comparison, this is the new automated tracking process. So everything is going from each of those sites directly to the sort yard and then is sorted at the sort yard. And this is a close-up look of the automated ground-based harvesting process. And then we'll scroll up and have a quick look at some of the inputs and data that are used to run the model. So we've also been doing some validation of our simulations of the conventional harvesting processes, that is, because the automated processes don't yet exist for us to look at real-world data. But we've been using the benchmarking data provided by the School of Forestry at the University of Canterbury. So they have 1,600 unique entries from over 12 years of harvesting. And they've been able to provide us with annual summaries of various operation types. And we've been using the best operational match to validate our simulation outputs. So this is a table comparing our simulation outputs in tonnes per days with what the benchmarking data suggests is really happening. So overall, things look to be fairly consistent with reality. The biggest difference we notice is here with our swing yarder 2-stage skidder. It's still well within the 95% range. However, there's no distinction made in the type of 2-stage harvesting happening in the benchmarking data, while we're specifically in our model looking at the swing yarder. But this gives us an idea of how much we can trust the simulated automated operations. So if our simulations of existing operations are fairly consistent with real-world data, which they seem to be, then we should be able to be fairly confident that our automated operations are also going to produce an accurate picture of what will happen in the real world. So this is a summary of financial measures looking at a 20-year period. So comparing our current harvesting processes with the new proposed automated process, we can expect a nice increase in the net present value. So going from 5 million to 85 million. Our return on invested capital increases from 7% in the current process to 24% in the new process. And the payback period from investing in setting up a current process versus a new process goes from 14 years down to just 4 years in the new process. So the costs of setting up are higher in the new automated process. The machinery is a bit more expensive to purchase initially. And our total startup cost is also increased. But our annual labour costs are decreased as we're decreasing the number of personnel. So we're going from 5.1 million per year down to 4 million per year spent on labour. And our trucking costs per tonne are also decreased. So instead of $8.10 per tonne, we're down to $5.90 per tonne. And our total cost per tonne of logs produced is actually going from $40 per tonne down to just $23 per tonne. And we're also increasing the throughput in this process as well. So rather than processing just 230,000 tonnes per year, we're able to increase that to 420,000 tonnes per year. So we have decreased our operation costs and increased our revenue. Just a summary of everything I've spoken about this morning. So we're comparing the proposed automated harvesting process with current practices. We've developed simulation models using XtendSim, comparing 4 existing harvesting operation types with 4 corresponding automated operations that have been proposed. And the results have been an increase in system throughput. We've also conducted some validation of the models using benchmarking data and developed an economic model to assess the costs and benefits of automation. So we've seen that we can increase the revenue and decrease the operation costs. And some of the next steps is we need to undertake some sensitivity analysis to identify some of the factors that are important in driving this benefits from automation, and some of the break-even points involved as well. And we're also looking at bringing forestry companies on board to use company-specific data and to develop mathematical optimization process so we can identify the best combination of automation for a specific company. And we're available for customizing the model to your harvest operation if you're interested in being involved. So thank you.